This is the PowerPoint modeling, if you will, of the analysis of unemployment rate by state for 2015 versus 2016 for the BGEN 202 class. We have started out, the data that we have is we've captured the unemployment rates for each state and the District of Columbia for 2015. I think that was September of 2015. And then we captured those same unemployment rate statistics by state for 2016. And so we've matched those up in pairs, and we want to compare what's happening sort of state by state and overall, given that a year has passed. Obviously, what we're really interested in, first and foremost, is there some relationship? And by some relationship, what we're basically asking is, can you look at the unemployment rates for a particular state in 2015 and use that as some sort of an indicator of what it would be for that state in 2016? Obviously, it's possible if there are some fundamental factors that are driving lower unemployment rates in some states and higher unemployment rates in others, you would expect that to persist over time. On the other hand, if it's just sort of a random outcome, then there's no particular reason to believe that a low unemployment in one year should be followed by a low unemployment in the next year. It may be high, it may be average, no particular reason to think one thing or the other. So the first thing that we did was to plot the unemployment rates by state on a scatter plot. You can see the 2015 rates are down here, 2016. And so if you looked at any one dot on the scatter plot, the way to interpret that is the value here would be, as an example, about, let's call it 3.2%. So the unemployment rate would have been about 3.2% in 2015 and maybe a little bit lower than that. Looks like maybe 2.9% in 2016. So you could pick out any 2 points here. You've got a 2015 rate that's about 5%, maybe a little less. And here in 2016, it had dropped to about maybe 3.6, 3.7%. So basically, these are pairs. Each of those pairs represents a state. So that would have been a particular state that had a 2015 unemployment rate of about 5% and a 2016 of about 3.7. Now, I can't tell from this plot which state it was. We would have to go back to the data to figure out which state represented by each dot. But the question we're really asking here isn't about a particular state. We're asking in general, are unemployment rates by state fairly consistent over time or more or less random, and therefore the rate may be higher than average in one year and lower than average in the next. So what the plot tells us is that certainly down here at the low end, we have states that tended to have lower than average unemployment rates. Think of the average as being kind of the middle of the data. They had lower than average unemployment rates in 2015 and also had lower than average unemployment rates in 2016. Up here at the high end, we see lower than average unemployment or higher than average unemployment rates 2015, and also higher than average in 2016. So there does seem to be some relationship. The relationship's a little bit more muddled in the middle here. The 2015 values, let's just say, are right around 5%. And yet the 2016 could be anywhere from 3.7 to looks like maybe 5.7 or 5.8. So it could be anywhere from a little below to a little bit above for the same 2015 or approximately the same 2015 value. So what it seems to be is that if your unemployment rate was right around average for 2015, then it's maybe a toss-up of whether it's going to be above or below average for 2016. But if it was quite a bit above average for 2015, It's likely to be quite a bit above average for 2016, and same thing with below. That's kind of what that relationship suggests. We can put a trend line to this data, and that's the first thing that we've done with the chart, is put a little bit of a trend line to it, and that gives you a lot better idea of sort of the relationship. Now again, the relationship looks a little bit tighter, maybe out at the ends, and a little bit sloppier in the middle. So that would suggest that it's not a super strong relationship, and maybe it's stronger for the more extreme results versus not. When you calculate statistics for it, the descriptive statistics, of course, we calculated the ones that we've already discussed in the past, the mean and the standard deviation. You see in 2015, 4.9, 2016, 4.74. Looks like on average things have decreased. And so again, that's, let's just say for 2015, right around here, 2016. So here's kind of our mean point, is somewhere right in here, all right? Now, one of the features of this trend line is that it needs to go through that mean. And so probably about right here, I'm guessing. Doesn't mean any one dot has to have that value, that pair of 4.9, 4.74. Just means that the line that we draw would have to go through it. So it's going to be about right around in here. We also see that the standard deviation is right around 1 for the two samples, a little bit lower than 1 in 2016, a little bit higher in 2017. That standard deviation, you can think of that for 2016 as being that the middle's about here. And as we know from the empirical rule about, the vast majority of the points are going to fall plus or minus 2 standard deviations from the mean. And so we're at about a 5 here, go to a 4, go to a 3. So they're going to fall between 3 and 7. And sure enough, we see the data falling between 3 and 7 here. Same thing here, it's about 4.74, let's call it 5, so it'd be again between 3 and 7. In fact, the statistics and the chart are consistent that way. Now we have calculated this one additional statistic now. This is our correlation. And the correlation in this case is 0.87. What does that mean? You need to think of it in sort of two pieces. The first thing that you want to think in terms of is that a positive or a negative number, or is it effectively 0? But let's just stick with, is it a positive or negative number? If it's a positive number, what it means is that to the extent there's a relationship, the relationship tends to, the trend line of that relationship tends to be low on the left and slope up towards the right. If it were a negative, then it would tend to be high on the left and slope down towards the right. And so positive slope, negative slope. And that's, from a sign standpoint, that's really all that it means. It does not mean that it does not tell you whether it's going to be a steep slope or a relatively flat slope. The correlation doesn't tell you that. In fact, you figure that out from the relationship between the two standard deviations. The magnitude of the correlation, so in this case 0.87, the closer that number is to either 1 or negative 1, the more tightly these dots on the scatter plot would be clustered around the line. And so if we had a correlation that was, say, 0.99, these dots would line up almost perfectly in a line. There wouldn't be a whole lot of this dispersion around it. If, on the other hand, we had a correlation that was closer to, say, 0, then what would happen is these dots would start to spread out around this line a lot. They'd be a lot wider out in different directions. And they may spread out so much that, quite frankly, you can't even figure out where the line would go. And so as the magnitude gets closer to 0, it gets harder to make sense of the line. And in fact, when you get to a correlation of exactly 0, it's just not possible to put a line through that has any slope to it. And so you would just put this straight flat line across, and that would be a correlation of 0. So that's the one time where there's some relationship between slope, and it really has less to do with the fact that there's a relationship, a slope relationship, and more to do with the fact that we can't figure out whether there's any relationship at all. So sometimes that's a little bit confusing about this. Bottom line is, as long as the correlation isn't very close to 0, you just pay attention to the positive and the negative values for it for slope. You don't really, or for whether it slopes up or down. It's not about whether or not the slope is very steep or very flat. Again, that gets determined by the standard deviation. From looking at the data and looking at the plots and looking at the statistics, it seems clear that there is a pretty strong positive relationship, positive sloped relationship, think of it that way, between the level of unemployment rates in a state in 2015 and what the level would be in 2016. It's not a perfect relationship, and we see that it's probably stronger in the extremes and maybe not as strong in the middle. And the mean and the standard deviations are quite similar for the 2 years. This leads us to think that maybe there, while within, certainly for any given state, there's some sort of a fundamental driver that causes some to have lower unemployment rates and other have higher unemployment rates. That the deviation in any 1 year between whether or not you have a low rate, lower than average rate, whether your rate from 1 year to the next goes up or goes down from the prior year, there's so much variability around how that happened that it's possible that quite frankly all we're seeing is a sampling randomness. And so, for example, if we had in a particular state that the let's just say that the unemployment rate was 4% in 2015, it's possible that it's completely random whether or not it will be a little above 4% or a little below 4% in 2016. And so there may not be as strong a story at this point for that unemployment rates really went down. Just because the mean went down a little bit, went from 4.9 to 4.74, it's not really possible at this point for us to say that that demonstrates that in fact unemployment rates went down. And so the next steps that we would probably take on that would be to do some hypothesis testing of differences between the means of those two variables to see in fact whether or not there's a statistically significant difference between the mean of one or the mean of the other. And that's what we will work on next.